people ask about this one. So this is page 29, number 20. Okay? So we have, I think the first thing that's important is we have to get in a habit of trying to read this. All right? So if you could turn next to someone real quick, and I don't care who does it, I want you to try and read this in English to someone next to you. At least that much of it. I'll pause. Go ahead. All right.
No, that's great.
That's beautiful. You sound great. That vertical bar is such that. The braces mean we have a set. A set of what? Well, a set of ordered pairs, x, y. That means we're in that world. We're not in the number line world. We're in the coordinate plane. Okay? It's the set of points, x, y, such that what happens? Well, they actually give me two conditions for this problem. They're going to tell me that x lives between two numbers, and they're going to tell me that y lives between two numbers. Yes, follow? Oh, wait a minute. I did one thing wrong. I notice in the book, that's not a less than or equal to, is it? By the y, what do they have? Strictly less than, okay? Which is going to be a nice teaching opportunity for me. See, Stitz is always thinking when he writes this stuff. So this is good. So we have negative the square root of 2, and we have 2/3. That's the limits for x. And we have pi, and we have 9/2. Okay. So I want to sketch a little graph of this. I should have used the graph paper, but we'll go ahead and make our own here. Okay. So let's see. In the x direction, we want x to be between negative square root of 2. Where's that? Well, we did that yesterday on the calculator. It was about negative 1.4. So I'm going to say that the farthest to the left we want to go is somewhere around here. There's negative square root of 2. And the farthest to the right we want to go, again, if these purple are the units, 2/3, well, that'd be about right there. Okay? So there are the limits along the x-axis that I want to go is right about there. Who follows me so far? Okay? So x has to be somewhere between there. Y, I guess I'll do that in red, y has to be between pi and 9/2. Now 9/2, that's, well, 4.5, right? Uh-oh. That's way up here. 1, 2, 3, 4.5. So the largest that y can be is up here somewhere. Yeah, real nice teaching, huh? All right, and you guys signed up for this. And then the smallest that y can be is where? Well, whatever pi is. It's a little more than 3, right? It's a little more than 3. Is it allowed to equal 3, the pi? It's not allowed to equal pi. And the way we'll symbolize that is we'll put a dotted line. Now, I compare that to, remember on the number line problems we had things like this. We had the open interval 2, 3, right? But sometimes we make this 3 and we put a bracket there. And what would that mean? That would mean we're allowed to equal which number? We're allowed to equal 3. We're not allowed to equal 2. And we are allowed to be 2.5, for instance, or any number in between. So I compare this dotted line to that open circle. We're not allowed to equal, well, I'm going to label this is pi right here. But we are allowed to go as high as 9/2. Now, there are an infinite number of possibilities, and so we shade in this region to call it the graph. And so again, you know, I guess I can go as far as here and as far as here. Oh, okay, as far as there. And so the region should be something like this. It's going to have 3 solid lines and a dotted line around it. Okay, so we were asked about number 24. Uh-huh. Yeah, so there's this relation, right? And it says, the directions say, please express the relation in set builder notation or roster. A roster would mean I know every single point that's on there and I'm going to list them. Now, how many points are represented here? Well, infinitely many, right? We need a whole interval if you want. I guess if it were me, this is how I would approach 24. I'm looking at that picture, and I'm saying, well, it's a set of ordered pairs. Okay? And now, looking at it again, let's see, what do we know about these ordered pairs? Well, can you tell me anything you know about the ordered pairs that are in that picture? What about negative 2? For all of them? Right? Isn't it true the x is always negative 2? All right? So you could say the set of xy such that, and now here's your equation, Mitch, x equals negative 2, because Mario said, hey, we're going to always be on that line. Now what about y? Y has to be, well, where? We have to be greater than or equal to negative 4, and we have to be strictly less than, you're not allowed to be equal to 3, right? This is one answer. But I'm going to do one more thing for you here, because it's done in the book. I saw it on the earlier exercises. They'll write it this way. They'll say, well, why don't we just say, instead of calling it x comma y, since x is always what? Let's substitute that in. The set of the set of points that are of the form negative 2 comma y, such that y is greater than or equal to negative 4 and less than 3. Barbara, was that your question? You see that? It's just they're trying to save some writing. Okay? Go ahead. Both ways.